27 किलो कर गया है। और वो पहले वेबिनार समय पे ही होती है, टाइम पे ही होती है, बढ़िया है ना, टाइम पे आगे।
Hello.
Shailesh sir.
Yeah, Manish, good afternoon. Yeah.
Sir, good afternoon, sir. As this program is very specific to this specific line group, and we have about 80 participants, so we may actually
We,
start.
okay, we may
It's
start.
just 1 hour program, so I think we'll just start.
Okay, so I think 4 to 5:30 we'll have. Okay. So I think it's time for me to welcome all the participants. So a very good afternoon to and warm greetings to one and all who are participating in this webinar, which is part of webinar series being held at Lighthouse Project sites. I welcome you all on behalf of Ministry of Housing and Urban Affairs, Government of India, on behalf of Building Materials and Technology Promotion Council, and also on behalf of GIZ and on my personal behalf. Although our Joint Secretary and Mission Director is not able to join because of accident meeting, but I also extend very warm wishes. He has already sent his wishes to all of you, and because he's the constant source of encouragement and motivation for conduction of these webinars across the country. I also greet and welcome my co-host, Shri R.K. Gautam, Director HFA5, Manish, lead PMU, and Mr. Vikas Ranjan, who's Director Climate Smart Buildings GIZ. I also welcome other officials from Ministry, PMU team, GIZ team is stationed at LHP site, and also welcome to the experts from BMTBC, Mr. Jha and Pankaj. The dignitaries, engineers, and officers from State Government of Gujarat, SLNA, Rajkot Municipal Corporation are also welcome here, including SLTC, CLTC team, engineers, and architects of other state-level nodal agencies. The representative of Messrs. Malani Construction, who is the agency executing the project at Rajkot, along with the Messrs. Otinard, the technology provider of tunnel form work, and their entire technical team are also welcome to this webinar. At last but not the least, I also welcome my Technograhis friends who registered through online enrollment drive initiated by Housing Forward Directorate and participating in all the webinars very enthusiastically in such a large number and posing a lot of good questions. We have now more than 34,000 Technograhis, and they are the ones who will act as catalysts to bring this technology transition in the construction sector. In addition, we also have engineers, architects, planners, professionals, faculty members, developers, technology providers, and the students from engineering and architectural colleges from all over the country. You all are welcome here. Today is the seventh webinar, which is being held at Rajkot LHP site. We have already completed the first round of webinars at 6 LHP sites, and now this is the second round. In the first round, we have given you a brief exposure to the 54 innovative systems which are shortlisted through Global Housing Technology Challenge India and being promoted within country, followed by an exhaustive technical presentation on specific technology being used in that specific LHP site where the webinar was held. In case you missed those webinars, the presentation along with recordings of all the lectures can be accessed through gstcindia.gov.in website. Today, we will get further deep insights into the technology, its implementation through a virtual tour, and if possible, we will also show you actual hoisting, assembly, installation, and other aspects related with the on-site works. The webinar is also being streamed online, if I am right, on YouTube. Even though it is being repeated time and again, but for the benefit of all of you, let me again apprise you that at present, to showcase these innovative construction systems, 6 lighthouse projects are being implemented in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Ranchi, and Agartala. All these 6 lighthouse projects, 6 distinct innovative technologies are being used, and we are holding these webinars at all these 6 places for participants to get on-site exposure and opportunity to learn all these systems. In addition to these webinars, Ministry of Housing and Urban Affairs in association with GIZ are also organizing physical training programs called Rachna, not only at all these 6 LHP sites, but also in different parts of the country for educating the stakeholders about innovations and also about the functional aspects such as thermal comfort, affordability, disaster resilience, sustainability, and green interventions. These projects are called lighthouse projects because they are being projected as live laboratories, which means learning the different aspects of design, construction, at site through large scale citizen participation. Therefore, whole set of activities are planned at LHP sites, which includes webinars, webcasting, physical training, site visits, and interaction. We have also developed e-knowledge pack for Technograhis in self-learning mode, which all of you can take and get a certificate. It's again available on GSTC website of Ministry of Housing and Urban Affairs. In case you are professionals and would like to take deep dive, Ministry of Housing and Urban Affairs in association with BMTPC and School of Planning and Architecture, Delhi, is also running a paid e-certificate course on innovative construction system called Navriti, where for 8 days, 3 hours each day, detailed lectures are being made by the experts from academia, industry, and research institutions, followed by interactive session. So the next batch will be starting from 27th May, and if you are interested, you can register by visiting the GSTC website or BMTBC website. So, dear participants, by running so many programs concurrently, Government of India is offering all of us a unique opportunity to learn the field level application of these innovative construction system in real time and build capacity so that these systems can be further adapted, suiting to our requirements, our geoclimatic profile, and replicated in our future construction activities. So please make full use of this opportunity. Let me also, again, for the sake of repetition, tell you that these innovative systems are very relevant in today's context, as globally we are committed to bring resource efficiency, energy efficiency, eco friendliness, and disaster resilience, and take our country towards sustainable and inclusive development. Also, all of you might be hearing that we are very fast urbanizing and we have to build pretty fast. So these innovative construction systems need help us to fast track the construction process, and also help deliver superior affordable housing infrastructure, which is better not only in terms of structural performance but also in terms of functional performance in comparison with the cast in situ frame construction or brick masonry or other stone masonry construction. So far, 6 webinars have been conducted. This is the 7th one in row, and by November we would like to hold 40 webinars. During these webinars, as Manish was telling you, we'll be taking you to the virtual tour of LHP site and try to give you glimpse of the project and also the on-site activities. With this, I sincerely hope that you all will be benefited by this webinar and learn new methods of construction, which will help you in your future projects. And what we have planned today is, after my welcome address, I will ask Manish to play a LHP film for all of you, a 5-minute film, which will give you overall picture of the LHP site at Rajkot. After that, expert from BMTVs will make a presentation on 54 new technologies, which we are promoting very aggressively across India and trying to make them future technologies of construction sector. And after that, specifics on technology will be detailed out, followed by a presentation by technology provider, where he will be showing you how tunnel form system is being manufactured. And if time permits, then we will again show you the cycle, how fast you can construct using this tunnel form technology. And then later, after virtual tour, we will take up the Q&A. So with these few words, again, welcome you all, and I request Manish to play the film on LHP.
Yes, sir. I'll just connect the film.
In the meantime, he connects. Yeah, he's connected. Yeah. So you can also go to Ministry's website, and we have created a section of webinars on LHP, where you can get all these presentations, recordings, and films. Okay.
Sir, can you please confirm if the video is visible?
Sound is not coming. Video is coming, but sound is not coming.
Now?
No, sound is not coming. Manish, no sound.
Is it not audible?
No, no sound.
Can you check again? Give me a second. I'll
Yeah, no issues.
Manish, बोलो.
Sound नहीं आ रही.
I think it will connect now. Give me a second.
No issues. Take your time.
Yeah, it did.
Yeah.
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse project using monolithic concrete construction technology with tunnel form consisting of 1140 feet in S+13 configurations, along with all basic and social infrastructure facilities, is being constructed at Rajkot in partnership with State Government of Gujarat. Honorable Prime Minister laid the foundation stone of 6 lighthouse projects, including at Rajkot on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। राजकोट में टनल के जरिए मोनोलिथिक कंक्रीट कंस्ट्रक्शन इस टेक्नोलॉजी का उपयोग करेंगे। फ्रांस की इस टेक्नोलॉजी से हमें गति भी मिलेगी और घर आपदाओं को झेलने में ज्यादा सक्षम भी बनेगा।
Work on Lighthouse Project Rajkot start all 11 towers, which are now in different stages of construction. This video briefly shows the progress of this project till date. An already established system for building construction in many countries. Monolithic concrete construction system replaced the conventional steel or plywood shuttering formwork system with customized engineered system. 2 half shelves made of steel are placed together to form a room or shell, and several such shells make the apartment. In tunnel form system, walls and slabs are cast together monolithically in a single day. Tunnel forms are used over foundation with necessary reinforcement, walls and slabs together using designed concrete. The sequence of construction includes stripping of the formwork on the previous day, its positioning for the current day phase with the installation of electrical and plumbing services, placement of the reinforcement for the wall and slabs, and then concreting. Construction of LHP Rajkot was started with excavation of site mostly rocky and removing the boulders and soil, followed by laying of plain cement concrete, footing work, shear wall, casting of plinth beam and backfilling substructure. As the substructure was completed in a tower, superstructure work was started by placing customized 2 sets of tunnel form simultaneously with reinforcement and placement of service pipes as per the design. and then pouring concrete to complete one floor in a day. Following the same process, casting of 8 out of 11 towers have already been completed, and works on shell remaining 3 towers are in different stages. While the superstructure is progressing in different towers, masonry work using AAC blocks, construction of stairs, fixing of electrical and plumbing services, lift installation, fixing of door and window frames, internal and external plasters, and painting are being done in a planned manner. Simultaneously, infrastructure works of drainage, sewerage, internal road, underground water tank, construction of compound walls are also going on. Construction of social infrastructure of including Anganwadi, shopping complex, and community center are also going on in full swing. A sample flat with all amenities in Tower 8 is ready for showcasing to the beneficiaries and other stakeholders. With completion of about 70% work, the project is likely to be completed very soon for handing over to already identified beneficiaries. The Lighthouse Project Rajkot is serving as live laboratory for learning and knowledge dissemination. About 300 Technograhis and other stakeholders have visited the site to learn the use of innovative technology in real project at site.
Thank you, Manish. And I think you might have got the idea of the technology here. And two words are being repeated in this video. One is monolithic and another is tunnel form. So it's a customized formwork which is made in the factory. So we will be showing you the manufacturing process as well. And monolithic means the walls and slab are cast together. So that is why it is called monolithic concrete construction. And this is excellent as far as disaster resilience is concerned. Earthquakes and cyclones and other things. Now, I will ask the nodal officer because, for each lighthouse projects, we have a expert from BMTPC. Yeah, Manish, you want to say something?
Sir, I think do you think we should show the film of casting yard also? It's a 2-minute film.
Casting yard, let me ask Jha, do you want to show it later or right now? Jha?
Planned, sir, after my presentation, but if you want to show, then.
Just for continuity, Manish, once he makes the presentation, then he will show the technology, then casting yard, and then the manufacturing process and all those things. Okay, so I just wanted to make a point that it is called monolithic concrete construction. So please bear in mind, monolithic concrete construction means walls. Otherwise, you have infill walls of bricks and all. Here the walls are RCC shear walls, and those walls are being cast with slab. So it is called, so there are no joints, and this is called monolithic concrete construction, which is excellent as far as earthquake or seismic resistance is concerned. So with these few words, I will ask my nodal officer, because for each lighthouse project site, we have appointed a nodal officer from BMTPC. They all are civil engineers, and we have today with us Mr. Jha of BMTPC. He will first explain you quickly the 6 broad categories and those 54 technologies which were shortlisted during the Global Housing Technology Challenge, followed by specifics on the technology being used here, and then we will show you the film of casting yard, manufacturing process, and then if possible we will take you to a virtual tour and try to show you that cycle of 3 days or 6 days, whatever we are getting. So over to you, Jha. You can share your screen and make your presentation.
Thank you, sir. So I, C. Jha, and Deputy Chief with BMTPC, welcome you all again to this webinar session 7. I will just start with this our Pradhan Mantri Awas Yojana urban scheme and its achievement. It is a flagship scheme of Government of India, and it is one of the largest housing scheme. If we talk of its achievement, 1 crore 22 lakhs views have already been sanctioned. Out of that, about close to 1 crore, that is 98.36 lakhs houses have already been grounded, and 58.68 lakhs houses have been completed and handed over to beneficiaries. Financial commitment is also very high. Government of India has committed 2,03,000 crore of rupee with a total outlay of 8.3 lakh crore of this entire Pradhan Mantri Awas Yojana urban scheme. It has generated this breakup of this houses sanctioned, grounded and completed are also given on the screen. It has created huge employment also. 686 person days, crores of person days have been created, out of which 212 is the direct one and 474 is the indirect one. Similarly, this 76 lakhs jobs, direct jobs have been created, and this 169 indirect jobs have also been created. It has this contributed to economic growth of this two primary this industries like cement and steel industries also. About 412 lakh metric ton of cement has already been consumed in the houses which is like presently under construction and completed, and it is expected that once these entire 122 lakhs are houses are completed, so 757 lakh metric ton of cement would be consumed, and similarly this 93 lakh metric ton of steel has already been consumed, and it is expected that with completion of all these houses, 172 this lakh metric ton of steel would be consumed. So it has contributed significantly to the growth of these two sectors also. Now this GSTC, as we are already aware that our Ministry of Housing and Urban Affairs have taken a very ambitious initiative of this Global Housing Technology Challenge India. Basically, that transform the this construction sector. Out of this, identification and mainstreaming of proven demonstrable technologies was very important component, and under that this this technical evaluation committee constituted by this Ministry of Housing under the chairmanship of DGCPWD, 54 technologies under these 6 broad categories of technologies. Like you can see on the screen, these are 6 broad categories. 54 technologies have been shortlisted. Using the technology from each of the broad categories, 6 lighthouse projects are being constructed. You are already aware. These are the screenshots of that foundation stone laying ceremony, which was held on 1st of January 2021 last year. So these are the actual screenshots. Then I come to this the system which we are presently following. The system which is presently being followed is, one is load-bearing structure. In the load-bearing structure, the wall of the building acts like load-bearing member. The load of slab is taken to the taken by the load-bearing wall, and that is transferred to the foundation. However, this has become nowadays sort of obsolete. Even under this Pradhan Mantri Awas Yojana, BLC construction projects also, people are this agency based on the wishes of this general public, they are designing the houses with columns and beams for the simple reason that once they want to go for this one upper stories and all, so they will simply take the project the columns and they will construct the house. But so this load-bearing structure is getting obsolete. Second one is the RCC framed structure. This is main construction method in which RCC columns, beams, and slabs are cast in situ. In situ means we put the formwork, we do the reinforcement, put the reinforcement, and then pour the concrete in situ. So this is the most prevalent way of construction nowadays. All the multi-storied building, high-rise stories, high-rise buildings, you see those 90% of that is RCC framed structure only. Though this alternate technologies now have started penetrating into this sector, like particularly the monolithic concrete construction and the precast concrete construction. So we are seeing the scattered use of those technologies, but otherwise this is the most prevalent system nowadays. Why do you want to use alternate construction system? What is the issues with the this one conventional construction system? First one is slow. Like speed is the one of the most important parameter. This is slow. Why it is slow? This is multi-stage process. Here in conventional building, we are talking of this primarily this RCC framed structure with infill wall. And alternate construction system is like we are now aware of that it is factory produced or based on the casting yard at site which produces the components. So the underlying fact is like in this alternate construction system, since there is use of factory or casting yard where better environment and regulated environment is there, so there is scope and potential for producing better quality of products. And in this conventional construction system, so since everything is done at site only, so it is very difficult to monitor the entire site with the kind of control and even the quality of this masons and all. So that is not of like a good order. So these are the these two things define the conventional construction system and this alternate construction system. In conventional system, we have this maximum use of natural resources. It is primarily sand, this aggregates, cement, water, and burnt clay bricks. Against that, if you see in this alternate construction system, so entire walling is replaced by either sandwich panel, which is produced in the factory, or like even the through this engineered formwork and this precast concrete components. So entire walling system is replaced here with factory produced components. And these factory produced components, some of the sandwich panel, they use alternate materials also like polystyrene, polystyrene's particles as a substitute of which is used in this manufacturing of lightweight concrete and all. So those kind of things are also used. Similarly, like glass fiber reinforcement, reinforced gypsum panels and all. So they use minimum quantity of this sand, or even the cement quantity is very, cement is very limited in that GFRG panels and all. So we optimize on the use of scarce resources, which is like sand, aggregates, and this water. Water also, like in a casting yard, we can recirculate. With the same water can be used for curing like n number of components, produced components, which is not possible in case of this construction site. Waste generation here, in case of this factory setup, there is proper protocol of this utilizing waste. So we have a better waste management. It is again reused immediately. Pollution control. So pollution control, it is difficult to exercise control at site, because like you cannot have this as a level of control as you can this adopt in the factory kind of setup. So pollution is definitely lower than the factory setup. Labor intensive, like if we make the columns and slab, so you need a labor force which is like used for the making formwork, then the shuttering for the slab and all. In the industrialized system, using the molds you this produce the components and those are erected. This is prescriptive design. This is cost effective, means performance based design is there, which is cheaper. In terms of quality, indoor quality also, since we in the factory setup, we have better knowledge and we can use better product and which contributes in better health and productivity also. With this exercise, this control and quality and all, so we say that life cycle cost of this alternate houses constructed using this alternate technologies is low. Life cycle here, I would like to mention that this comprises of initial cost of construction, then the cost incurred during the operation of the building, and third parties, the cost of disposal of building. Since the potential for maintaining quality is better in case of this precast item or this alternate construction system, so we have a lower operation cost in this system as compared to conventional system where very good quality control cannot be exercised at the site. So life cycle cost is lower. And if we use lower energy, so this makes a reduction in this use of energy also, which makes the factory-based thing energy efficient. Cost in situ is generally poor quality because, like I said, that now the skilled labor is skilled mason is a thing of prime concern in this conventional system, and exercising control on the quality at such large locations and all, and which is very well, which can very well be maintained in the factory setup. Low CHG emission, if energy is lower, then proportionately the greenhouse gas emission is also lower. If we use optimized resources, we use lower energy, we this minimize waste, so that all results in sustainable construction as compared to the conventional one. So like by design or the precast thing or alternate construction systems are efficient and this sustainable. We now talk, nowadays talk of this safer structure, safer that stands for sustainable, affordable, functional, economical, and resilient. And why this sustainability aspect is so significant? In case of this sustainability, our building this contributes about 30%, up to 30% of use of energy, 30% use of water, and 40% generation of waste as a total of this, total consumption of energy, total consumption of water, and this waste. And if we go for the sustainable construction, so there is vast potential of reducing the energy use, which is up to 30 to 50%. Means if it is 50%, so energy which is available today, so it can be extended for just double duration. If we and similarly water, it has potential to reduce 40%. 40% reduction in water use, which can extend the life of our existing this potable water reserves. 35% reduction when energy is reduced. So in this proportionate manner, the CHG is also reduced. It has major potential for reducing this up to 75% of the waste material. Waste material, we are also taking a lot of measures in our lighthouse projects. Like we are treating the wastewater from STP to this. We are recycling and treating that STP water. We are also doing our this waste recycling. The organic waste recycling provision is also there in LHPs. Now I will talk of the 6 broad categories of technologies which have been shortlisted. And first one in this is this a modern technique, which is most advanced technique and being implemented at Ranchi. So we are replacing the entire conventional system with this customized factory-made volumetric construction. Volumetric construction, you can see this is like entire module is being this cast and being erected. So the process involves, this is the mold. From mold, this component has been produced. The component has been transported to the site, and from the site it is getting this is the project. This is project site itself, and it is through the tower cranes and all. It is erected. Under this like PSTC, so there were 4 such technologies along with the technologies provider. So they were shortlisted. Ranchi, this technology is being implemented. The construction system. So there were a scattered use of this 2D construction system by this L&T and Sirke, but this is also one of the broad categories in which individual components, not the entire 3D, but individual components like wall, slab, staircases. So they are produced in the factory and they are transported, erected, and joined in situ. So these are the various components which are assembled at the site. So there were total 8 technology providers which were shortlisted under this this category of 2D precast construction system. This is being implemented at Chennai, and I am happy to say this is on the verge of completion. This has project is almost complete. Then there is pre-engineered steel structural system. In this system, concrete columns and reinforced concrete columns and beams are replaced by the steel, steel columns and steel beams. Here you see that steel column is there, beam is there, and infill wall is with aerocon panels. So these panels are aerocon panels, lightweight panels. Construction is very fast. These are the light gauge steel structures. So light gauge steel structures are very thin. There's a cold rolled steel sections. So you can see, and there is limitation that we cannot go more than G+3 story in this system. So they together, light gauge steel, steel structural system and pre-engineered steel structural system, they form this category, this broad category, and there were total 16 technology providers shortlisted under this system, under this category. This technology is being implemented in LHP, Agartala. Next is prefabricated sandwich panel system. In this prefabricated sandwich panel system, the entire wall is replaced by the factory produced sandwich panel systems. These panel systems are of various category. One is like you can see that starting from the top, this is EPS system where the inner core is expanded polystyrene sheet. Over that concrete is sprayed. So this is called EPS, reinforced EPS system. Then there are other panels like which are like this one. Outer 2 sheets are there, and inside this PPGL. So inside some foaming material or some insulation materials are kept. So these are the components. Even the staircases and all can be made using this EPS system. So about 9 such technologies were shortlisted under this category of prefabricated sandwich panel system. In the LHP, this Indore, so the steel frame is there. This is a hot rolled steel section, and Rising Japan sandwich panel is being used as infill wall. So these infill walls, like I was talking, that it uses EPS granule balls to produce lightweight concrete, and this lightweight concrete is between two fiber cement board panels or the silicate panels. So this makes the walling this very light and very high in insulation value also. So these help in this reducing the operational heating and cooling cost of the building also. Initially, these panels were manufactured by firm in China, but now this two plants in Nagpur and Pune have also been installed and functional. Next one is like our monolithic concrete system. This I will cover separately also. So I will not this will cover this subsequently. So this is like the tunnel form which you have just seen in the movie. And I will talk about this one, the last system, which is a stay-in-place formwork system. This stay-in-place formwork system, as its name implies, that this formwork system stays with the building only. Like unlike the normal shuttering and formwork system, or even the engineered system, this formwork system, it stays with the building only. And inside, generally, concrete is poured, reinforced concrete is poured. You can see in this the cavity you see here. This is like walling with this stay-in-place formwork system. This is also one type of a stay-in-place formwork system where this the two outer panels are with the steel cages. This LHP at Lucknow is being constructed using this stay-in-place formwork system, but this is like PVC system, which is like pre-finished kind of wall, and reinforced this one concrete is poured inside that two pre-finished like outer layers. So this you can see the reinforcement is projecting out, and concrete would be poured in this, and this is pre-finished wall. Now this one, like under our PMAY also 16 lakh houses are being constructed using this new technologies, alternate technologies. And this is the position of coverage by CPWD, approval by CPWD, and SOR issued by CPWD on this. Here you can see on the screen that individual component and the most primary this way of construction system is like this one, which we are using. But we have reached up to this stage also, where you can see that this entire module is being erected, and the building is using these modules. But we have to reach the level 4, that is like pre-fabricated and pre-finished kind of thing. Now I will just go through this one. Our project at LHP, this Rajkot. So there are 11 towers, and 11 towers, they this typical floor plan comprises of 8 DUs in this fashion. And this is the layout, project layout. Carpet area is very high, 39.77. This is the configuration of DU. Even the study room is there in addition to one bedroom. And the green features include like STP water recycling, solid waste management, renewable resources, solar. This one is there, use of solar energy, and this rating by Griha of 3 star, minimum 3 star. So this we have already seen in the movie. So this is 2 inverse L, which completes this one formwork system. And as we have seen that this is this is a stripping of formwork. It is shown here, which is being transported and getting installed here. We keep this reinforcement cage ready for walling, which we put by the side of this formwork. Here you can see this reinforcement is put. Then above that, this on the slab also, with the help of this concrete cover. So we will put the slab reinforcement, and then we do the concreting in one go. I will. Acha, here you can see that ideal this cycle of this technology is 24 hours. Now, again, like when we put the reinforcement here for the walling, so there are many this electrical boxes, switches, they have to be installed in the room. So these are already welded with the reinforcement, and all the conduits also, you see, these are tied with the reinforcement, then they are put, and then concreting is done. So this has been shown here. So this has been installed, tunnel formwork, and over that, like you see that in half portion already reinforcement has been put, and here also reinforcement would be put, like you see this one, and after putting the reinforcement, the concreting is done. So the stage today, like this is the figure of May 2nd. 9 blocks out of 11 blocks have been completed, and only 2 blocks remain. Here I will do some analysis of like what has been achieved. We say that our cycle time is, ideal cycle time is like 24 hours. But what we have been able to achieve? So I will just highlight that. Our first superstructure work started on June 21st. So June 21st, and it is going to be completed in this month only. Like as on date, 1072 DUs have already been constructed. The remaining are 72 DUs, which make it 1144, and they will be completed by about May 15-20. So we, in 11 months time, starting from June 20 to May 20. So we have taken 11 months. In 11 months, we will be completing 1144 DUs. It means 3.5 DUs per day. But this is like from the start of work of superstructure. That was June 21st. Before that, foundation was completed in many blocks. If we talk of like this cycle, like the ideal time is 24 hours. This ideal cycle time is 24 hours. In this case, we are doing construction here with 8 number of this sets, which is like a 2 group of sets of 4 DUs each. Like total 8 DUs set are there, have been used in the project. So with this like 8 DUs, 143 repetitions have been made. 143 repetitions have been made, and with this we have achieved a cycle of 2.3 days. Not bad. 2.3 days is can be considered as reasonably good. And I will be like sharing with you the in some cases, and present in the present time when there is like hot climate and all, and concrete is getting strength, good strength at early this one hours only. After like 15 hours, we are stripping this formwork, and with this we are able to achieve 30 hours of cycle also, which means 1.25 days. Against the ideal, this 24-hour cycle, we are able to achieve 1.25 days. 30 hours per cycle. So, and had we used this 3 sets, means a set for 12 number of DUs, we would have completed the building at the same cycle rate only by February 10th or 15th only. Had we used this 12 number of sets for this. These are like the various stages. You can see this. This is using this tunnel formwork, and this front side, which is open, which is used for extraction of for stripping of this formworks and all. So this is constructed using this autoclaved aerated concrete blocks, which is like also very environment friendly and resource efficient material, and very light in weight, and have very high value of insulation also. So this is the position, tower 1, 2, 3, 4, 6. Even the community buildings like Anganwadi, community center have been like, you can see that external work, plastering has also been done. And this is the actual photograph. This is actual photograph like what we see saw initially. So this is now this. In fact, as of like May 2, 2022. So this gives a impression of like building is almost in the completion stage. So with this, like I thank you all, and if you have any clarifications, so please like you can ask. So with this, I conclude, and next, should I upload this casting yard?
Yes, yes, Jha sahab. You can upload this one.
Okay. So now, are you able to see?
We are not able to see the video.
Okay, okay, just a minute. अच्छा वो ऑलरेडी था स्क्रीन में. नहीं स्क्रीन अच्छा स्क्रीन शेयर करना ठीक है. Just a minute, waiting some. Mr.
Do you want me to play it again?
Please.
Yeah, sir. You want me to play it again? I have the better quality video.
Hi, if you're playing the video again for Utinor factory, I can talk about the process which was shown in that. I thought we were going to play the casting yard video. Anyway, so if you could play it again, please, I will explain the thought process.
This is our plant.
Thanks. So this is an overview of our factory in Pune, where we manufacture tunnel formwork system. So from here, we are not just doing manufacturing for India, but that's how these separate components are manufactured. The whole process is controlled to give us the precision. This is an overview of how the components are being painted so that they withstand the weathering condition. I hope everybody is able to hear what I'm saying. So, and that's how the panels are loaded onto the truck and then they arrive at site. That's where they are assembled. And once the assembly is done, then they are put up in a location for us to take the casting.
Yeah, please, you continue.
Okay, so I will continue with my presentation. So before that, let me welcome everybody, all the participants to this presentation, and let me start by thanking BMTPC, in particular, Mr. Jha, Mr. Gautam, Mr. Manish, and last but not the least, Mr. Agrawal. And I will start with giving you a brief introduction of how we started with Utinor, all kinds of system formwork, and then I will go on to explain how the tunnel formwork system works, please. Okay, and then we will take it forward like that. So give me a minute to start with my presentation, please. Okay, I hope everybody is able to see the screen.
Yes, we can. Samitji, please continue.
Okay, so welcome everyone. So I will just give you a background on how Utinor came about in terms of our company was established in the year 1955 by the gentleman called Mr. Charles Bohr. So this we started, or rather he started the whole thought process of coming up with a cast-in situ technology just to address the challenges which were being faced in Europe, where they started using concrete as a building material. In fact, this is kind of similar to what is happening in India today, where we started using concrete as a building material majorly, and where precast was the, of course, obvious choice to start using. But then you have these logistical issues in terms of where you have your factory set up at point A and then you have to use it at point B. So carrying all these components to the site become challenging. So to address these issues, he came up with a cast in situ technology, and that's where what we are doing in simple terms is to create a mold at site and to create the structure that we want to get, and then you pour your concrete in it, and then you have your structure ready. And then what you do is what we I mean, in today's form and shape, as we are offering this technology today, we call it the industrialization of the construction process, wherein we are trying to use least number of components, using less dependency on labor, less dependency on not just the number of labor that we use, but also on the skill set of the labor. And then by that we are doing a repetitive process so that the whole team becomes efficient and we get the result that we want to do in terms of getting a good quality construction with fantastic tolerances and at a very very good speed, again looking at the kind of housing requirement that we have in India today. With that as a background, let me just go to explaining to you the process of how exactly tunnel form gets used. Okay, and I will now show you the video exactly how we use it. Please. Okay, can you see the video screen, please?
Yes, go ahead. Go ahead. Yeah.
Yes. Okay.
Okay.
So small clip, a short clip rather, which explains how exactly the tunnel formwork system works. Okay, we of course start with the architectural drawing as the basis for us to design. So before that, what we do is we do a due diligence or a feasibility report of the layout as to making sure that the project that is being considered is fit for us to use a tunnel formwork system. And once we have done an analysis like that, and if we find that the project is suitable for using tunnel formwork system, then we come up with a tunnel formwork layout to address the design needs of the layout. So this is typically how the tunnel formwork is made. In terms of, you have two L-shaped profiles which combine together to give you a tunnel. I mean, we call it a tunnel, but we can also be referred to as a room form. So wherein you are casting a room. So this is how we identify an architectural layout and see what all walls and slabs we are going to be casting using tunnel formwork. And then we divide a floor into number of pourings, so that at a time you are only doing a number of rooms, so that the amount of, as I spoke about industrialization, so the amount of components that you need to deal with for a single pouring or a single phase remain controllable, in terms of where I can ideally go for a 1 day cycle or a 2 day cycle achievement. Okay, so the of course all our components are made in high carbon steel, and the average weight of the components goes up to about 100 kilos per square meter basis. So you need to have some kind of mechanical means. So for typically structures at a single place like a residential apartment, you end up using a crane. And we of course also decide what capacity crane needs to be used depending on what is the size of the tunnel formwork that we will be using, the maximum size. And then with that calculation, a tunnel formwork is used to make for each pouring. Now here you can also see how working platform and site platforms are introduced for ease of construction. Typically, all the more when it is a multi-storied apartment kind of a construction where safety becomes a concern. So you have a very, very safe platform of 3 meter plus minus size all around the building, which gives you that safety. So with this thought process, we continue on a daily cycle. Now I will explain to you the actual daily cycle. So as there are these two L-shaped components of tunnel formwork, right? And out of that, we first start striking only one half of the tunnel, and we start stripping, and after that we do repropping of the slab. So the repropping is done to keep the slab supported, and then the tunnel is picked up and taken to the next phase where we need to do the pouring. And for the next phase, we already have the wall steel tied in place, along with all the window cutouts or the door cutouts, the detailing which is going to come in, all your electrical fixtures, everything. And once all that is done, when you bring your second component or the second L of the tunnel or the room form is also brought in place, and then you're introducing your box outs. You can see that this shifting of components or pulleys, as we call them, is done using a crane. And then, of course, you tie your slab steel in place, and then you get your concrete in place. So this is the process, simple process, which is repeated a number of times to get us the desired result that we want. So just to give you an idea, at Rajkot site, as Mr. Jha mentioned, that we've been able to achieve a cycle of per pouring of about 1.25 days. So, and an overall cycle of 2.3 days per floor is what we've been able to achieve. So that is the kind of speed with which we can proceed, and that is the kind of speed and efficiency that we can achieve on a tunnel formwork system. Okay. If time permits, I would like to show you some of the daily cycle process slide, and followed by some of the examples of the project that we are doing worldwide. Can I do so?
Yeah, please show cycle. Yeah, please show cycle. Yeah.
Yes, so I will show you the cycle time, please.
Projects are not required because they want to know about the technology.
Okay.
Okay,
How
so
the
you
24-hour cycle works. Yes, let me show that, please.
yeah.
Okay, can you see the slide which says 24-hour cycle?
Yeah, go ahead.
Okay,
Explain.
perfect. So, typical cycle starts if whenever we are targeting a 24-hour cycle for one of the pourings, the cycle starts with first thing in the morning to first check the concrete cube test. Okay, for the pouring which we have done on the previous day. Okay, only after we get sufficient strength in the concrete in the cube test, only then we start with striking of the forms. Okay, so first thing in the right hand side corner picture, you can see that first we are there are only three parts when I'm opening or when I'm doing the de-shuttering. I have to open out the junction between the two tunnels. Then I have to do the de-shuttering using the cross member over here. And then after that, there is a mechanical jack at the bottom which allows me to bring the formwork down. So it releases from the slab and also the wall surface. Okay, these three steps are done. Then the number of labor which we need to work. Okay, let me just add that also. A typical set we need to have about 15 odd labor to be present at site. Okay, then these people are required to push the tunnel form out onto the working platform physically, and there are wheels which are provided at the bottom of the tunnels for them to facilitate this operation. Once the tunnel has been pushed out onto the working platform, then you attach it with a crane. The crane picks up and takes it to the next cycle. Once I start doing my this process, then as I explained for the second pouring, I will already have my steel tied in place. I will already have all my electrical conduits, any other utilities if we want to bring it into it, that. And then we also have your door frame blockouts, your window frame blockouts all placed in location. You will also notice that next to the door there is a small height wall which you can see. So this we call as the kicker block or the starter block. So this is an integral component of our system, which when I'm casting my slab, I am also casting this kicker block, because that is what gives me a guide wherein all my walls across floors are going to sit exactly incidental onto the wall which is coming from the ground floor itself. So there is no question for me to go away in terms of or missing the alignment of the walls, and also in terms of it doesn't allow me to miss any of the 90 degrees in the structure. So this is one of the feature which allows me to have very low tolerances in the structure. So coming back to this concrete kicker block, they work as guideline for the crane operator to locate the formwork also in place. You will also notice these orange color cones which are there. So these are the cone covers for my tie rods. The tie rod holds two sides of the formwork in place, and it also helps in not just maintaining the width of the wall which we need desire to have it, as well as it allows me to take the concrete pressure for the formwork in place. So once I have brought in all my components in place, you can see that that's when I start introducing my slab steel. Okay, before that, let me also add that once I start picking up my formwork from first pour and when I bring it to the next pour, each and every time it is must that first we clean the forms, we oil them with shuttering oil, and only then we reposition them. This is a very important step, that once we follow this simple process, the quality of concrete that you will get, because our system is designed to give us F5 or fair face finish concrete. Okay, so as long as we follow this simple process, all the repetitions which the tunnel form is designed, instantly we are guaranteeing minimum 500 repetitions on our tunnel form system. So all those repetitions will give you the F5 or the fair face finish concrete quality. So coming back to the process itself, all the utilities are placed within the wall, and then you start introducing your steel for the slab portion. So you introduce your steel, you are also introducing your electrical conduits and everything. And remember that since this is a load-bearing wall, a monolithic construction, which is load-bearing walls and slab construction, so we don't really have very complicated steel, or neither do we have a very high dimension of steel in terms of the diameter of steel. So it becomes very, very easy and fast to introduce the steel also in place. So you get your steel in place, you get all your electrical conduits, everything in place, and then by the end, once I have finished with all these activity, say sometime late afternoon, I am ready to start with my concreting activity. So once it is done that, we start with concreting, and the process is same, that we start filling up the walls first, and once all the walls have been filled, that's when we use concrete for the slab. So like that, walls and slabs are cast together in single go. Then we, of course, we use vibrating equipment like needle vibrator to make sure that the concrete goes and sits in all the nooks and corners, especially where we have door cutouts, window cutouts, and so forth. And then once the de-shuttering happens, we have good quality concrete surface, which, let me add that we don't need to do any plastering once we have a fair face finish concrete surface on this. So typically on the external surface, you could go for coarse painting on the outside, and as far as the inside is concerned, we can go for a putty and paint kind of a thing. For the external, a texture finish is what I mean.
Mr. Bapat, if you can please quickly finish, we will take the
So, fine.
participants to
So
the site
this
also.
pretty much finishes my cycle for a 24-hour cycle. So that's how my cycle ends, please. Okay. So once my concreting has been done, then for Indian conditions, of course, although here we've shown that we need to use heaters, but this is more for the low temperature climate condition. For most of the Indian region, we don't need to do this. And that's when you repeat the whole process by starting at 7 o'clock next day. So thank you so much. That's all I would like to share. And of course, I'll be available for any Q&A session to follow later on, please.
Samir, quickly, you can tell them the cycle you're getting here for those.
Yes, so just to add, picking up from what Mr. Jha had presented, the cycle for each pouring that we are getting for Rajkot project is 1.25 days, and overall we are getting a 2.3 days cycle for the floor. And in totality, we are finishing a still plus 13-story apartment building in about between 35 to 40 days time. So that is the speed with which we are able to finish, and that's the kind of cycle which we are
in
able
3
to
days.
achieve.
So in 3 days, your built-up area is around 8 units.
That's right. Of 8 units on each floor. Yes.
So 240 square meters
Yes.
in 3 days.
That's right.
Okay. And 11-story building in 45 days.
A 13-story building in about 40 days, 40.
Okay, that's wonderful.
Yes.
So thank you, Samir. Thank you, Samir. And now, Manish, let's take them for a virtual tour.
Thank you so much.
आप कुछ और ऐड करना है क्या? Thank you, Samir. Very nice.
Yes, thank you.
Just wanted to add that you have been able to achieve 2.3 days. Like it is not 3 days.
Yes, it is less than 3 days.
All the difficulties, site disruption and all. So it is 2.3, not 3.
Yes,
and,
thank you, Mr. Jha, for pointing it out. Our average cycle is actually 2.3 days.
2.3 days, not 3.
Yes.
And
not 3 days.
Don't get into decimals. Don't get into decimals.
And 30 hours is the highest you have achieved.
Yes, 1.25 days.
Let's say 3 days only. Let's not bring it to decimals. Okay. So now let's take a virtual tour. Manish, if you can help them out.
Sir,
We have shared the live feed from the site.
Okay.
Jignasu if you are available over there, then please explain the technology over there.
इसमें कुछ दिख इसमें तो there is nothing to see. If you can show, there's nothing to see here now. You take it up inside so that we can explain them. Who is operating video camera there? See what you see in Samir. Would you like to explain or shall I
Yes,
explain?
please. Let me do that, please.
Yeah.
So what we are able to see is that the tunnel form work has already been finished for, yes, when we are zooming, and you can see that the secondary work of facade work, which is being followed from floors which are coming from below. So typically you can see a zoom of the facade work which is being finished. So typically what we are depending on is to do parallel processing. So when I'm finishing my upper floors with my tunnel form work, I can follow it with the secondary work of your internal small walls as well as your facade walls to finish. So in this case, because the structure is only G plus 13 or still plus 13, we have gone for AAC block with plaster only for the facade part of it, because the heights are not so great. But otherwise also we could go for, say, a precast element or a cast in C2 technology to finish the facade also. But the essence is that it is a parallel processing. When I'm working on my tunnel form work on upper floors, I'm finishing all my other works also. So overall, you are still able to get a time cycle which is following in line with the tunnel form cycle that we are achieving. So yeah, you can also see some of the other building over here now.
Is something happening on the site?
Of course, they are right now in terms of stage. Yeah, they are finishing the last two blocks inside, please.
See what is, yeah. See what is trying to explain you. This is a tunnel form. So he showed you that inverted L. So what you see in this now, this is a finished building. The earlier picture which he showed is that the kind of tunnel you get, okay, and then these outer walls are filled with any infill material. Here we are using AC block, and what Samir was trying to explain, that instead of AC walls, you can have a ready-made facade. You know,
Yes.
Jha was talking about precast concrete construction. So you can get the facade readily available from the factory and just install it. So the idea here is this kind of rectangular thing, which is being produced monolithically using this tunnel form. And now you can shift to next building. So this kind of thing you get, then as he was telling you, once you finish one floor, you move to another floor with the tunnel form, and the floor below you can finish the services and all these things, AC blocks and all these things. You know.
Yes, you can follow it with the finishing item in terms of your tiling and everything, so that
That
everything
is what.
becomes like a
Yeah.
parallel processing, and then you are finishing it much faster. And also, just to pick a point of which Mr. Agrawal had mentioned earlier, that this kind of construction, because the cross bracing happens at a more regular interval, they perform the best when it comes to earthquake resistance.
And what you can see here, you see the earlier picture which we showed was without infill, and now this is a finished building, and here already they have done this masonry work, okay, of AC blocks.
Yeah, and on the right hand side, you can see all the plastering has already been finished also.
And again, as Samir was telling you, again, for the sake of repetition, everything is being done concurrently. So
Yes.
many operations are going on concurrently or simultaneously, like infill, services, painting, and one side you are getting the structure erected through tunnel form. And one side you are getting the structure erected through tunnel form. So anything else?
Yes, and now we can see some of them are also painted. So this is what we generally refer to as the industrialization of the construction process. So you have one team dealing with only one aspect of the construction, so that the efficiency of the team becomes much more.
Okay.
In one of the buildings, concreting is taking place, so they will just show the concreting part.
That's good.
Okay.
I think the arrangement is done at the site level. They will only operate the camera right now.
Okay, so site, if you are hearing us, somewhere you are getting
Hitesh.
so show that, yeah. इसको बड़ा कर दो यार, मनीष बोलना इसको hit HIT. If that can be put on the
Is
screens.
Hitesh there at the site? Yeah, Hitesh is connected. I think if you can just show the concreting right now. Yeah.
Yes, so we can actually see the process of concreting going on right now.
उसको बड़ा करो यार.
If
See what you see here, they are doing the concreting, okay? So you can see
So
that.
the formwork is already in place. You can see, you can also see the steel is already tied with all the utilities tied in place, and then they are spreading the concrete to get the final surface finish. Of course, the walls are going to be formed with the formwork itself, surface of the formwork itself, and the top of the slab is leveled to give us the requisite leveling as far as slab is concerned.
Correct.
You can see the pump which is throwing the concrete in place, and then it is being spread by workers around.
so, I think the catch here is if the person who is carrying the camera there, Hitesh, if he will speak, then we may see the better view.
इसको बड़ा करो ना यार स्टेज
Can
पे
you आप कुछ बोल सकते हैं हितेश?
इसको बड़ा करवाओ यार मनीष, ये छोटा आ रहा है बहुत.
सर आई थिंक वो कैमरे के का सेटिंग इनका वो है. लैंडस्केप में एक बार बात करो जरा.
I think there is nothing more to explain because it's a very simple thing. What Samir was telling and what Jha was telling, once you erect the reinforcement, you have the formwork, you are pouring the concrete, and now concrete is being labeled, okay, at the slab level. And after this, you will remove the formwork the next day, and then you get a very good smooth finished surface. And since again and again we are telling, because slab and walls are cast together, so there are no joints at all. So the entire L, what you saw, inverted L, two inverted L joined together to make a tunnel. And this tunnel is monolithically cast in a single pour. And that's what is shown here, that reinforcement of slab, reinforcement of wall, and right now through pump they are pouring the concrete, and that concrete is being spread into walls and slab. Am I correct, Samir?
That's right. You're absolutely right, sir.
Okay. Okay. Yeah. Now it's a better view. Yes.
Yes. So this you can see now the lapping reinforcement for the next floor. Also, you can notice because that's where we'll connect when we will go to the floor above this. And as I was mentioning, the starter blocks are also sitting right on top of the walls which are coming from below. So your incidence, it coincides exactly on top of the walls. So your alignment issue, everything is taken care of this way.
Just for the benefit of all the participants who are engineers and architects there, just now Samir told you lapping. So this is very important because it's a reinforced concrete construction. So you need to connect your floors together monolithically. So you require these bars which are coming from the down floor below. They should go sufficiently into the floor above. So there are codes available, the ductile detailing codes which need to be followed. So depending upon the diameter of the bar which you are using, you have to provide a sufficient lap. And if required, you need to use welding. What you are doing here, you are doing it through winding wire, isn't it?
Yes, this is normal lapping with binding wire.
It's a normal lapping, and wherever you have lapping, the horizontal reinforcement, spacing of this is a vertical reinforcement. So these starter bars need to be connected with the bars of the floor above with a sufficient lap. So please understand that lap is must, and wherever we have lap, there we need to have a horizontal reinforcement at a denser spacing. Okay, so that is very mindful, and that need to be checked by the third-party quality agency. Okay, so that detailing is very important. What you see here in this picture is vertical reinforcement.
Yeah, so you can notice the starter block also and also the lapping length of the steel for vertical, which is being visible on the left side of the screen.
So what floor we are seeing? Just out of the curiosity, what is this? Some floor or something?
Yes, it is a floor. Which floor is
Floor is
this?
this?
Okay, unfortunately, even I'm not aware exactly
Anil,
which floor level
Anil, can you
we
tell?
are.
Anil is there. I see my.
अनिल
Anil,
ये
बताओ.
This is
10th
ninth
फ्लोर पे
floor
हो रहा है या
of last
7th फ्लोर?
tower, number 5 actually.
Number 5.
11th फ्लोर.
Fifth.
Ninth floor.
Ninth.
This is the ninth floor of tower number 5.
Okay. Okay. It's a ninth floor concreting of tower number 5. Okay. Fine. Good. Good.
So if everything goes well, Samir and other experts, how much time it takes to complete one floor, just for the sake of the participants? How
Yes.
It
much
will
time
take 4 hours
exactly,
actually.
on an average, how much it takes?
Can I
It takes
tell?
4 and
Yes,
4 hours actually.
I will let Mr. Jha take this one, please, because he
Samir,
has the exact data.
Actually, they have a set of 8 units. So 8 unit from starting to finish, it is taking on an average 2.3 days, like 52 hours. So 52 hours, you are able to construct 8 units in a floor. Though the fashion is slightly different because they are constructing 4 units in one tower and 4 units in other tower. But the two together takes 2.3 days to complete the 8 units.
Yeah, wo question. The question is right now they are doing this concreting. How much time it take? 4 hours, 2 hours, 3 hours. This particular concreting of
4
it.
hours.
This single pour. This is a single pour. Okay.
Yeah.
In this, how much time is taking? That's
It
what
is
he's asking.
concreting for 4 units takes like 4 to 6 hours. 4 to 6 hours for the entire concreting.
Right.
And stripping time is like 15 hours nowadays, because in 15 hours it achieves a strength of 8 MPa. And before
नहीं नहीं ये
stripping,
नहीं अनिल ये बताओ ये जो कंक्रीटिंग हो रही है कितने घंटे में खत्म होगी ये जो अभी कंक्रीटिंग कर रहे हैं अनिल
हाँ हाँ सर.
ये कंक्रीटिंग जो हो रही है कितने घंटे में खत्म होगी कितने दिन का ऑपरेशन है ये
4 hours. It will take 4 hours, sir.
so that is the answer Manish to your question this is 4
So-
hours they will finish.
So basically, for our social media purpose also, so this is faster than the conventional system.
much faster.
And how
It is, and if
much
I
is the
may
difference?
add,
What about the
yeah.
conventional system? अगर ये 4 घंटे में होता है तो कन्वेंशनल में कितने टाइम पे हो पाता? सेम एरिया, सेम फ्लोर.
कन्वेंशनल में भी मान लीजिए वो 5 से 6 घंटे लग जाते, बट वहाँ स्ट्रिपिंग जो है मिनिमम जो आईएस कोड अलाउ करता है मिनिमम 3 डेज है स्लैब में, लेकिन किसी भी प्रोजेक्ट में इट इज नेवर स्ट्रिप्ड इन 3 डेज, इट टेक्स 15 डेज, बिकॉज स्ट्रिपिंग के बाद भी वो सपोर्ट वर्टिकल सपोर्ट रखते हैं. सो दे इंस्टेड ऑफ मोबिलाइजिंग लेबर्स ट्वाइस, वो क्या करते हैं कि 15 दिन के बाद वो स्ट्रिप हटाते हैं. अगेंस्ट दैट यहाँ पे हम 16 घंटे में हटा रहे हैं. So this is much faster.
Manish, just to add to what Mr. Jha said, the timing for concreting per se doesn't change whether it is conventional or whether it is technology here. Okay, the difference come in the previous two activity as I was explaining. The first activity is to get the formwork in place, which in our case happens within 5 to 6 hours time. Which a conventional formwork you can take number of days. Just to first removing the formwork and then also to add it for the next pour. That's where the difference in the overall timeline comes in. That is my first activity. The second activity is also to tie the reinforced steel, because we are tying the steel in a conventional method for our vertical members first and then we add our slab steel in place. So that is the second activity, which is again a much more laborious and lengthy in terms of running into number of days at sometimes. Okay, so these two activities is where we say when we go for a system formwork. As far as the third activity of concreting per se is concerned, the time remains the same. Okay, so what we say in terms of an overall cycle is in the first two activities of stripping and installing the formwork first, and second getting the steel in place.
Thank you, Samir. Actually, I was just trying to understand the nuances. Basically, we are preparing some of the highlights of the project, LHP projects, because we are right now doing for Chennai. Chennai is going to be inaugurated by Honorable Prime Minister anytime soon. So we are doing that for Chennai. So I thought, why not ask these questions also?
Yes,
Do you
yes.
also save some of the number of labors also,
Yes,
in
so
terms of
just to answer
labor
that,
quantity?
typically you need only about 15 number of people to work on the form work part of it, because most of the work which we are carrying out is using a mechanical means, which in this case is a crane. Okay, it's a crane which lifts the tunnel form work from one location and it shifts to the other location. So that's why we need to spend, very minimal amount of form work, and that's what going back to the industrialization of the process part of it, where we are using mechanical means to reduce the work and getting the efficiency for an overall cycle.
Great. Thank you very much. I think the floor is open. I think if you have any questions, any participants have any question, why not ask? Otherwise, we are almost done. Sir,
Okay. We will just see whether there are questions. You can put
if
your
any
questions here.
questions are there,
Box. There are no questions at all.
I think the floor is open. Anybody wants to ask anything, you can just speak.
Yeah.
No, I think we've been very particular about our topic, and people have understood. So I think there is no question as such. Great. So we'll end up, sir. Shall I
There
say?
are okay. There are no questions here. So I think Manish, it's time for us to wind up. So
Yeah.
we will ask Vikas to do the honors to propose word of thanks. And before that, you want to make some announcements? Acha, that is one announcement. Is still that is on now. We can all the Technograhis can go and visit physically these lighthouse project sites on 10th, 20th, and 30th of every month. That's
Yes,
on.
sir. Yes, sir.
That's
I
on.
think we've shared the link for Technograhi also. Whoever wants to register as Technograhi, they can. Number two, from our ministry also, next week is going to be a LHP site visit week. So everybody from our ministry is going somewhere in the LHP places. So whenever is anybody interested to visit the site, they are most welcome. We'll be there to support you. Otherwise, every 10th, 20th, and 30th, the site is open for Technograhis and other stakeholders to visit. And so we'll have these short uh, webinars frequently uh, to make people understand the technologies LHP wise. Sir, Vikas sir is not here, so can I request you only to just end up and thank everybody?
Being host ourselves, we cannot thank ourselves. So we would like to thank the Technograhis and
Yes,
participants for
yes,
making this session interesting. And I would like to especially thank Ottinger team for explaining so nicely and technically the entire sequence of operation. And we will be requiring you, Samir, and your team, and Jignachu. I just got a message from Jignachu. He's there at the site, but because signal is weak and because of high winds and all, he could not get connected. So thank you very much for your support, and I'm sure it must have evinced a lot of interest among the participants, and they would be approaching you. So you can
Yes.
just write down your number here. If you can write your email or number so that they can directly connect with you and inquire further into these things. Also, just to add what Manish said, all these lectures, whatever today's proceedings are made available by our IEC team on the GSTC website, and the entire proceedings of today were also streamed live on YouTube. So you can go to YouTube and download the entire session as well. So with these words, with that, let me thank Manish and ministry's officials for making this webinar possible and making it interesting. Thank you very much. And before we depart, let's take a virtual group photograph. So request everyone to switch on their video cameras, and I'll ask Manish to take a photograph.
yes.
And in the
I want
meantime, let
everybody
me
to
take
show
this
their faces.
opportunity to thank Mr. Agrawal and the whole team again, once again, for giving us an opportunity to present the technology. Thank you
Thank
so
you.
much.
Thank you. Thank you.
Can I see more faces? Yeah. Thank you. Thank you very much. Great.
Thank
Thank
you.
you, sir.
Bye, bye, bye.
Bye, sir. Bye.